So thereby results to reduce mode loss and mode efficiency. See, already I have discussed this thing with you. The filter circuit increases the cost, weight, size, and at the same time reduce the efficiency and makes the transient sluggish. So sluggish, transient sluggish, obviously it will be generic. So thereby you can incorporate in the circuitry, but finally you suffer from these disadvantages on demerits point of view. And for large variation of output voltage of a constant load current, the control of DC voltage is not conductive. However, this can be overcome by incorporating a separate fixed DC voltage source with changing of commutating capacitor. But it makes the scheme costly and complicated. So whatever we go for design, always we should keep in our mind, always we should keep in our mind, so the system must be efficient and must be cost effective, uh, so thereby no problem will come. And another thing, before going to this, another thing is there. So as the DC input is decreased, the commutating capacitor, the voltage also decrease, voltage also decrease. This has the effect of reducing the circuit turn-off time of the ACR for a constant load current. Therefore, what we do for a large variation of output voltage for a constant load current and control DC voltage will not conductive. Will not conductive. This difficulty can however by overcome by incorporating a separate fixed DC voltage for charging the commutator for charging the commutator and thereby see we can overcome from the system, but always think this make the scheme costly and complicated. This scheme may become costly and complicated. Next is that how the internal how we control the internally of the inverter. We control, that means there is some internal circuitry modification is employed. Actually, which type of circuitry modification is employed for to get change the internal control of the inverter. The output voltage of an inverter can also be adjusted by, by incorporating a control within inverter itself. The most efficient method of doing this by using the PWM control, that means pulse width modulation control, used within an inverter. This is PWM inverter. And see how we can control PWM. So in this method a fixed DC voltage is given to the inverter and a controlled AC output voltage is obtained by adjusting the on and off period of the inverter component. This is this is most popular method of controlling the output voltage, and the method is known as your PWM control. Already I have just discussed this. There are some advantages are there. Which type advantage? The output voltage control with this method can be obtained without any additional component. That means the output voltage, you can control the output voltage by using this method without any additional component. So obviously, as there is no additional component are there, so this system must be more effective than you're using the more stages So thereby filter circuit is needed. So we can minimize this thing from the as we use in the external actually control method. And with this method, the lower order harmonics can be eliminated or minimized along with its output voltage, and as higher order harmonics can be filtered easily by filtering the requirement are minimized. And the these are the disadvantages basically. And the main disadvantages of this method is that the silicon control rectifiers are expensive as they must possess low turn off and low turn on time. And turn off and turn off time are very low. Uh, so thereby PWM inverters are quite popular in industrial application. For therefore, when you will go ahead for details in PWM inverter, then you can see how how it is operated and how we consider it. Disadvantage already you have got this. This is PWM inverter. Hmm. So see, my thing is that actually I can go ahead. This is your PWM inverter. Yes, I can tell the very brief in about the PWM inverter. The PWM inverter are gradually taking over the other types of inverter in industrial application. The pulse width modulation technique are characterized by constant amplitude pulses. The width of the pulses, however, modulated to obtain inverter output voltage control and to reduce its harmonics content. The different PWM techniques, there are many different PWM techniques are incorporated. The single pulse modulation, multiple pulse modulation, and sinusoidal pulse modulation. When you see the details, then you can see this is more interesting and how internally by controlling the internal itself inverter can control the inverter. In PWM inverter, there are force commutation is essential, and there are three PWM techniques. As I have told you, the single pulse modulation, the multiple pulse modulation, the sinusoidal pulse modulation. Uh, so each there are some differ from each other in the harmonic component in their respective output voltages. Thus, the choice of particular PWM technique depend on the permissible harmonic content in the inverter output voltage. In industrial applications, the PWM inverter supplied from a diode bridge rectifier and a LC filter. Uh, So as you know, guide bridge rectifier is incorporated. There are different topologies are there. There are many applications are there. The industrial application, and sometimes sometimes the your PWM inverter is incorporated in other application also in medical application, in your high frequency application. There are lots of application are there. So for electronics, so thereby you can see once we use the PWM inverter, so how we get the output of the inverter, how much harmonics will be generated, and the harmonics is totally depends on here also harmonic will be generated. Thereby the selection is needed. As you know, the single pulse modulation, your multiple pulse modulation, your sinusoidal pulse modulation. Obviously single pulse modulation, there will be a certain harmonic level. When you use the multiple pulse modulation, then corresponding you will get one type another type of harmonics generation. Once you use the sinusoidal pulse modulation, that means these are the types of pulse. These are types of pulse of the inverter. These are types of pulse of the inverter. रितेश चंद्रा, अभी इन कर रहे हो? See, thereby, see.